Hey everybody, let's start right into this with some evaluations of the unit circle. So let's work through this first table here in the day 5 notes. I've had to restart this video because of making small errors I didn't want you to see, so hopefully I can make it through this one with minimal errors, or if I do, I can fix them quickly. So anyway, you may see me refer back to my key that I worked out prior to. So tangent of 10 pi over 3. Let's find where that's coterminal. So 10 divided by 3 is 3 1/3. So we're going 3 1/3. So we're going to end here. So we know we have our point -1/2, -√3/2. Tangent is y over x. So this word gets a little interesting. I don't think we had any of these previously. We're going to have -√3/2 divided by -1/2. How do you work that? Multiply by reciprocal. 2's cancel, negatives cancel, you just get √3. Cotangent of 17 pi over 6 is definitely more than a 2 pi term, so let's get the 2 pi out of there and find out where we're coterminal. Hopefully 1 2 pi, if I subtract it, will get us there. So if we do minus 12 pi over 6, we get 5 pi over 6, which means we're here at the √3/2, which is negative, and my half. And I'm going to do cotangent, which is x over y. So I'm going to do that up here in the top. So x, -√3/2, divided by y, multiplied by reciprocals, and we get -√3. Tangent of 5 pi, that one will be a little quicker. That's 2 full terms and then something extra, so it looks like this. 2 pi, 4 pi, 5 pi, -1, 0. Tangent is y over x, or 0 divided by -1, which is 0. Cotangent, 9 pi over 4. I like those because we know they're going to be in those middle spots. And I think we could just recognize that that's more than a 2 pi rotation. So we do our 8 pi over 4 here, and we get that it is pi over 4 is where we're ending up. So we end here. And in that case, we're at √2/2, √2/2. Which means if we divide those from cotangent being x divided by y, we see √2/2 divided by √2/2, which is 1 because they're the same exact things. Or you could write it as this and see your cross canceling is going to give you 1. So that one's kind of quick. All right, next we got negative pi over 4, also kind of quick. It's down here. So we're at negative, nope, that's a positive √2/2. And a negative √2/2. Just making my x's and my y's. And we want cosine. Cosine is the x value, so you're a positive √2/2. Double check, make sure my notes that I'm going to give you are good. All right, that's good. Sine of 5 pi over 3. 5/3 pi. I'm going to count that one out. It'll help me get there on the unit circle. 1 pi over 3, 2 pi over 3, 3 pi over 3, 4 pi over 3, 5 pi over 3. So we're here, which means we're at 1/2 -√3/2. We're doing sine, and sine is the y value, so it's simply -√3/2. Double check. I like it. All right, cosecant, negative pi over 3. So we're just doing 1 pi over 3 term. We're going to end the same spot, right? This is a negative pi over 3. Cosecant goes with sine, so we're going to take that sine value and just flip it. So we want the sine, which is the y value, but we're going to flip it to 1 over y, or the reciprocal, and we know that the y value is -√3/2, so let's flip it and go 2 √3 negative. That's an okay answer, by the way. We could rationalize it and get -2 √3/3, which I like. Sorry, I made so many mistakes. I'm going to keep checking my key. I was just making tiny errors, and I just don't want to screw you guys up that way. So please bear with me checking my key that I made before I started this. All right, secant 3 pi. So that's 2 pi, 3 pi, so we're at -1 0. We know secant relates to the cosine, which is the x, right? So we want the x value. We want 1 over x. So we want 1 over -1, which is -1. Are we good? I like it. Okay, next. This is kind of the new stuff. It says, solve these, give your answers on the domain 0 to 2 pi, which means you're only looking at one full term, because otherwise it would be infinite for your answers, right? If you could say, oh, well, what about if I turned it 4 pi? Then I could have more angles in there. And there's another way to write this. You could write this, which you'll see in your homework. They mean the same thing. They mean where on the unit circle, in essence, what angle on the unit circle has sine relates to a y value of 1/2. Now, this might be better to go back to a completed unit circle that I have up here. Where are the sine values 1/2? So you guys may want to take a look at this or look at your own. I can see that the sine value is 1/2 at pi over 6. I can see that it's 1/2 at 5 pi over 6. So it happens twice where the y value is 1/2, pi over 6 and 5 pi over 6. Now I am going to get into something that's kind of just touching on the surface of what we're going to do with two possible answers, because not sometimes, when we start graphing these, you're going to see that the range, which is what we're doing, we're getting output here, or we're using the output to determine which one of these we pick. And basically it goes to this chart that hopefully will come out in the notes. And the chart basically says this: your answer for these type of questions has to correspond to particular quadrants. Otherwise, you're going to have double answers. Which one's right, which one's wrong? I'll show you. So we're doing sine, which is this guy. And you'll notice that I put a 1 and a 4. And I'll show you what that means. It means we're only going to look at answers for the inverse of sine in quadrants 1 and 4, because the range is from -√2/2 to +√2/2, which is quadrant 1 and quadrant 4. And so we go back to our work and find out which one of the angles was in 1 or 4. Well, this was in quadrant 2, so we don't want that one, we want this guy. And we'll do it again on cosine. So again, it could be written like this. And what we're saying is, okay, where is the x value? So what angle has x value of √2/2? Well, we know those are the pi over 4 ones, right? Those are my favorites because they really don't have to worry about flip-flopping anything. So we know pi over 4 accomplishes it. So we'll write that down. But where on the unit circle do you get another positive x pi over 4? And I believe it's in quadrant 4, right? So if you go in quadrant 4, you get a positive √2/2 at 7 pi over 4. Now which one do we want? Well, that's a little tricky. And we'll see, you see how I crossed off the 7 pi over 4 in the notes here? And the reason is, for this one, we're only going to look at quadrants 1 and 2 because we're only looking at the angle from 0 to pi. So look for your answer in quadrant 1 or 2. Quadrant 1 is this guy. That's good. This is not 1 or 2, so it's not that guy. Secant of theta is 2. What is secant? That is the cosine inverse, right? It's 1 over the cosine. And we know that the cosine is the x value, so we want, whenever we do the x value and we flip it, where is it to? So you think reciprocal of x value is +2. Where does that happen? All right, so we know we're going to need some 1/2s involved. So look at 1/2s, and that's what you want, because if you flip it, you'll get that 2. So if we come up here, all right, 1/2 x value. So I look at it, pi over 3 does it, and 5 pi over 3 does it, because those are both 1/2s in the x's, and we flip them and we get 2 over 1. So pi over 3 and 5 pi over 3. So pi over 3 and 5 pi over 3. Just make sure I'm not making another small error. Okay, I'm agreeing with that. So let's look at our secant range. So secant range goes with cosine, right? So in that case, you're looking at quadrants 1 and 2 again, right, down here. There's a little bit of a blurb in there that we'll hit on some other time, but it's still going to be quadrants 1 and 2. So what angle do we have here that's in 1 or 2? Well, the 5 pi over 3 is in quadrant 4, so we don't want that one, we want this one. All right, let's look at cotangent. This is where I was making some little tiny mistakes I don't want to make with you again. So cotangent is the reciprocal of tangent. Tangent's y over x, so we want the x over y. So where are we going to do an x over y and get 1 over root 3? A little tricky because you don't have any 1 over root 3's in your unit circle. And I'm just looking at my reference of the unit circle here to help me. What you want to think about is when I take a number and put it over a number, it's going to reduce to 1 over root 3. So you have to involve either the 30 or 60 degree angles because those are the only ones that have root 3's. So if I play with it a little bit and say, all right, let's just mess with it. All right, let's say we take the 30 degree root 3 over 2, 1/2, and we'll try it. So if we do x over y, this is kind of a guessing game, so to speak, until you get the hang of it. If I do x over y, I get this, which means I get this, which means I get this. And that's not what I wanted. I wanted 1 over root 3, which means I bet if you flip these and went to the 60 degree angle, 1/2 root 3 over 2, you'd get it. So let's try it. Okay, so we're going to go x over y. We're going to, I was already, not to mess it up. All right, 1/2 over root 3 over 2. Work it. Now it appears. So where does that happen? Not here. This is my 60 degree or my pi over 3, right? So we know it happens at pi over 3, which means it'll happen also where that's positive. We're doing cotangent, so that would relate to tangent. Where's tangent positive as well? And that's in quadrant 3. So it would also happen at 4 pi over 3. And which ones do we want? Well, if we look at tangent, we want quadrant 1 and 4. This is in quadrant 1. This is not in 1 or 4, so we want pi over 3. Double check myself here. Screwed it up again. Okay, let me fix it. So cotangent is my x over y. I just want to double check that I'm making this correct for you guys. So let's look at it with fresh eyes. I've made it through to this point with minimal errors, so I want to start over on this problem. Okay, cotangent of theta, 1 over root 3, meaning we want, again, x over y. And what I might have done is flip-flop them, but we'll just look at it. So either you have to use the pi over 6 angle of root 3 over 2 and 1/2, or you have to use the pi over 3 angle, which is the 1/2 root 3 over 2. So I'm going to jump. Maybe my key's wrong, and I didn't catch that earlier. So let's go back right to the pi over 3, which I thought was correct the first time. So we would do 1/2 over root 3 over 2, which is 1/2 times 2 over root 3. Yeah, I had it right the first time. My key that I had thought I did well, not so good. So we're at the pi over 3, and again, that would happen at 4 pi over 3 as well. Let me check real quick. Oh, they're all rationalized. Pi over 3 it is. Okay, so again, with the range situation with the tangent, we're looking at quadrants 1 and 4. This one happens in quadrant 1. This one happens in quadrant 3. We don't like it, so we're going there. Okay, please excuse my mistake. I actually had it right. I was second guessing myself. I apologize. Let's take a look at a couple here. So this is going further, and I know I'm going fast, and the reason is because I've tried these videos a couple times, and I screwed them up and it was taking too long, so I'm trying to condense, help you guys out, save you some time. So cosecant of theta is 4/3. Now, one thing you'll have to recognize is, and I checked with Ms. Sturgeon on this, we forgot a negative in this situation here. There should be a negative with this 4/3, so I want to throw that in there here real quick. There should be a negative, otherwise this doesn't work. So what we're looking for is the cosecant of an angle is 4/3. The tangent is positive and the cosine is negative. Well, where are the only places where the tangent is positive and the cosine is negative? Go back to this, A, S, T, C, right? Tangent's positive here and it's positive here. The cosine's also positive here. It's not negative, so cosine's negative in here. So we're making an angle happen in quadrant 3. So let's draw it, because you don't have a 4/3 show up on your unit circle. So go back to day 1 of this unit where we draw in the right triangle. There's my theta. Cosecant is negative 4/3. Well, cosecant, what we know cosecant is, it relates to sine, right? And we know that sine is opposite over hypotenuse, which means cosecant must be hypotenuse over opposite. So the hypotenuse is 4, and the opposite is negative 3, which means we need to find the adjacent so that we can answer the cosine and tangent questions. Well, if this is x and we go Pythagorean theorem, we can do it. We'll get x squared equals 16. Remember, this is going to become positive. So it'd be 16 minus 9, which is 7, and we get 7, we square root, we get x equals root 7. So here's root 7. Now we need to find tangent and cosine. Tangent, opposite over adjacent. So the tangent of theta, opposite, negative 3, over adjacent, which is root 7. We could rationalize that. In the interest of time, or I'll write it here and erase it. So if we do this, we get negative 3 root 7 over 7, which is good. So that could be a final answer. And then if we do tangent, oh, I did tangent, I didn't do the cosine. Cosine is adjacent over hypotenuse, which is, well, I think I made a mistake there, and that is this. Think about this for a second. If you go left in this direction, that should be negative, right? So it would really be over negative 7, which means negative, negative, which means this is positive. And you need to add that negative in there to make this work. So cosine adjacent, negative root 7, over hypotenuse, which is 4, and we can leave it there. That's fair enough, because we don't have to rationalize anything. All right, moving on. Okay. Secant of theta is 3. Sine is greater than 0. Sine is greater than 0 in 2 spots, so we're going to have to be careful about this one. It's in first quadrant and second quadrant. But secant is positive 3. So let's think about this. Secant is related to cosine, and cosine is adjacent over hypotenuse. So if we were to do hypotenuse over adjacent for secant, we get 3 over 1. It's kind of quick, but that's it. Hypotenuse is 3, adjacent is 1. And the only place that can happen where you go right 1 in your adjacent is in this quadrant. Because if you did it over here, you would go negative 3, or excuse me, you'd go 3 up here, and your adjacent would be negative 1, but it's positive 1 up there. Right. So let's start this over. We're going to say it's in the first quadrant. Here's theta. Secant is hypotenuse over adjacent. So this has to be our x here. So we're going to do 1 squared plus x squared equals 3 squared. And x squared equals 8. Square root it. X equals, there's a 4 into 2 root 2. Okay, so we have that. Now we can answer the questions. And I'll grab a different color. So we're doing cosine, which is adjacent over hypotenuse, which would be just 1/3. We could have done that one straight away, right? Because secant goes with cosine, we could have just flipped it. But then the tangent, we would need this. We would need opposite over adjacent, which is 2 root 2. All right, let's do sine. It's 3/7. It's a positive 3/7. So this one's not as bad. We don't have to think it's just y over x, or sine is opposite over hypotenuse. So the opposite has to be positive. Cotangent is negative, which means tangent would be negative, sine's positive. So that could happen in quadrant, not quadrant 1, because tangent would be negative there, or positive, and we want it to be negative according to this. So not there. So we'll put sine here. So we go theta, opposite, hypotenuse. This will be a negative number though, right? Because we're going left. So if we put an x there and we solve this, we get x squared plus 3 squared equals 7 squared. X squared equals 49 minus 9, which is 40. Square root it, we get x equals 4 root 10, or 2 root 10. So there's your 2 root 10. If you need help on those reductions there for these radicals, let me know. Or Ms. Sturgeon, I'd be happy to help you. And what do we have to answer? Cosine. So cosine of theta adjacent over hypotenuse, 2 root 10 over 7. And tangent opposite over adjacent. Well, we could rationalize that. So we get 3 root 10 over 2 times 10, which is 20, and that'd be good. All right, challenge question. Cotangent's undefined, and secant is negative. All right, let's try to think about this. Cotangent's undefined. Gonna have to have some zeros in the denominator, so cotangent meaning x over y, catching myself. X over y is undefined. Where does that happen? So x over y is undefined, meaning we get a y value of 0. So it should be here or here, right? No, I did it backwards. Just grab another color. See, my day off brain is not working. Okay, so it's here because we have a negative 1 comma 0. We have a 1 comma 0. And if you were to do x divided by y, you'd get undefined there. But it wants the secant to be negative. So secant is your what value? Secant goes with cosine. So you want your cosine value to be negative, which is your x, which is here. So that's what we're looking at. So we're using that point right there to do cosine, which is negative 1, and tangent, which is y over x, which is 0 divided by negative 1, which is 0. Ooh, okay. And then you guys should have some homework problems. Depending on what Ms. Sturgeon did for you or Mr. Beal, depending on whose class you're in, there's a lot of different things that can be used today. Pairs check, my open math reviews on all this stuff. So make sure you're checking with your teacher about what they want you to do. And I hope you guys have a great day. Sorry the video was so long. Please forgive my bumbles.